Good morning and good afternoon. My name is Adrian Constantin. I'm an application engineer with Dixieland, Germany, and I'm glad to be the host for this webinar for the PowerFactory 2017 What's New webinar. Thank you for allowing the time for joining the webinar. With me I have my colleague Deborah Cox. She's a senior application engineer with us, and she will be the presenter for today. Just a short introduction on the webinar format that we are having right now. You as participant, you are muted. This is just for enabling us for proceeding with a smoother presentation throughout the webinar. There is no chat area, but there is a questions field that you can fill in questions whenever you feel like adding questions throughout the presentation. You don't need to send in the questions at the end of the presentation. You can do it straight away whenever something pops up in your mind. At the end of the presentation, we will allocate a short period for answering some of the questions that are of general interest. And for the other questions, we will try to take them separately and handle them on a one-to-one basis. So I look forward to sharing with you today the highlights of the latest edition of the PowerFactory suite, that being PowerFactory 2017. And I will now hand over to Deborah, and she will take us through the presentation.
Good morning, good afternoon everyone. In the first part of this webinar, I will present a number of the new features via demonstrations in PowerFactory, and in the second part we'll give a high-level overview of other features which we think will be of interest. Starting with handling and data management. The first development is one which has been frequently requested by users, the ability to combine two or more projects. We now offer this option as a two-stage process. The first step is to bring two or more networks from separate projects into the same project using the Project Combination Assistant, and the second step is to connect them together. This second stage has been kept separate to allow users to carry out that process entirely manually if they wish. But a Project Connection Assistant tool is provided to automate the process. I will now demonstrate the process using two source projects, one being the model of a high voltage network and the other a model of a medium voltage network. There are two different methods for connecting the networks. The method which I will demonstrate relies on identifying common nodes in the two projects. These must be held in an identically named grid in the two networks, and the nodes to be merged must also have identical names. I have prepared my source projects accordingly. Here we can see the network, the net that has been prepared with the two nodes that are going to be used for connection. We can mark these in graphic. And they can be seen in these two parts of the network. The additional tools toolbar is selected, and the two projects can be combined using this button. Note that the projects must each have a version within them because this is what is used to identify the project combination. and then the combination is executed. The combined project here is automatically generated and activated. In the project overview, we can see that the data from the two projects are stored in separate folders, this way that their sources can be easily identified. Before the networks can be connected, a new study case is created and the networks activated. Then the project connection assistant is used to connect the networks. The connection method is by virtual nodes, and one of the virtual nodes grids is selected. Any other grids of the same name are automatically identified. We now execute the connection. It can be seen now that there is just one border grid containing the two nodes where the connection has been made. To show how grids are connected at this point, we can generate a diagram of the entire network using the diagram layout tool. Obviously, further modifications will be needed after the process is completed, such as removing loads which previously represented the medium voltage network. The second method looks for switches to connect the two networks. It looks for switches which are only connected on one side, then uses these to link the networks. Foreign keys are used to identify the pairs of switches. At each connection point, one switch is eliminated, then the remaining switch needs to be manually closed to complete the connection. In this project, the project has been configured so that this process could be used. Here we see the switches which are connected only on one side. In this demonstration, I have shown how projects can be combined to make a new project, but it is also possible to use the tool to bring additional networks into an existing project. Snapshot export. PowerFactory 2017 offers a new method for exporting and sharing project information. The Snapshot export function enables the currently active status of a project to be exported, such that only the relevant objects are included. Scenarios, variations, and characteristics are all consolidated. A project exported in this way is potentially a much smaller file, which nevertheless, when re-imported into PowerFactory, can be used to reproduce analysis carried out in the original project study case. In this project, there are a number of study cases and also several variations. I will run a load flow, and we can see the per unit voltages reflected in the colouring on the network. The project can be now exported using the project snapshot. I will now re-import the exported project. And we can see how there is now just one study case and all the variations, etc., have been consolidated. If again I run a load flow, the results will be the same as in the original study case. Moving to outage planning. In version 2017, a new concept for modelling planned outages has been introduced. In earlier versions, outage objects were created and applied to the network model to model the outages of equipment for maintenance, etc. The resulting network configuration could be saved in a scenario. Now the concept is that the scenario will model the intact system, and changes to the network resulting from outage application, such as switch positions and earths, are held in memory. This has a big advantage that it is possible to easily return the network to its original state, that is, reset the outages. In this project, a number of outages are defined. The new outage object has a start and end date, and the outage components are listed. But also, in a significant development, it is now possible to include other events in the outage object, such as reswitching of substations, load reductions, etc., which are to be enacted when the outage is applied. To start with, I will apply this outage as it is. We can see that the outage on this circuit has been applied and the breakers are open. In this particular network, we can see that it is desirable to have this adjacent circuit, which is currently off load, switched into service when the circuit beside it is on outage. This associated action can easily be added to the outage object using the record function. Now, if we look at the events in the outage object, under remedial actions, we will see the two switches that are closed in order to bring the circuit on load. Just to demonstrate how this works then, I will reset the outage and apply it once more. Now we see that the circuit has been outaged and the circuit adjacent to it has been switched in. To enable the easy handling of outages, a new outage planning toolbar has been provided. This button lists all the outages in the project. This one provides a list of outages valid for the study case time which are available to be applied. This one resets all the applied outages, and this one allows the user to select an outage for recording additional events. Lastly, there is a report button. The report function can be used to give an overview of the outages not yet applied to the network. If the start and end dates are automatically selected using the detect button, they will be taken from the earliest start date and latest end date of the outages. Moving on to graphical representation. In PowerFactory 2017, there have been graphical developments which allow sites to be represented. Site objects are typically used where there are two or more substations at different voltage levels in one location. In this example, there are two substations contained within a single site, a 400 kV substation and a 132 kV substation. We can represent this on an overview diagram by a single site graphic element. Here is the relevant part of the network in the overview diagram, and the new site graphical representation has been used. Then the lines can be redrawn to show the connections. It is also possible to generate a detailed diagram of the site using the diagram layout tool. And it can be seen that the two voltage levels are represented. There are some other new graphic features which I would like to demonstrate. Firstly, an option to enable anti-aliasing on diagrams. This gives a smoother appearance to curves and sloping lines, and is particularly useful if graphics are to be printed. Secondly, there are developments to the diagram layout tool offering extra options for the automatic generation of diagrams. I shall demonstrate how a feeder diagram is generated. And thirdly, also useful for distribution networks, a new layer is available to allow the user to see the open points between different feeders. The layer can be displayed on various graphic representations, such as overview diagrams and detailed substation diagrams. So, to see these various features in PowerFactory, first, the anti-aliasing option. If we look at part of the network, it can be seen that the angled lines have a stepped effect. The anti-aliasing is provided as a user setting option. And if it is selected, the diagram takes on a smoother appearance. Anti-aliasing is not automatically enabled, as it is less suitable for larger overview diagrams for performance reasons. The next function to look at is one of the additional features on the diagram layout tool. This project has a large number of feeder elements defined, and the diagram layout tool can now be used to generate feeder diagrams. A feeder is selected, and the diagram generated. Once a diagram is created, it can be customized, for example, to change the size of the object names. The other new feature relating to feeders, as I mentioned, is the representation of tie open points. The new tie open point layer can be made visible. And it will indicate the open breakers which separate adjacent feeders. The symbol that indicates the open feeders can be customized if required. Looking now at analysis functions. The protection audit module automates many of the repetitive actions carried out by an engineer when verifying the performance of a protection scheme. And it presents the results in such a way that weaknesses in the protection scheme can quickly be identified. The verification process involves the application of short-circuit calculations throughout a given network area. The user specifies the network area to be examined, then configures the fault cases to be applied. The protection devices responsible for each network element are determined automatically according to the circuit breakers that they operate. In order to use the protection audit tool, the network model must include a protection scheme for which all the settings have already been defined. The protection audit tool is accessed via this icon. The network area to be considered is selected here. And the types of faults to be considered are added here. In this example, we will look at faults along branch elements. When the audit is complete, the reports can be run. 3 types of reports can be generated. The verification of device coordination checks that there is sufficient interval between the primary, secondary and tertiary protection operation. Here, as in all the reports, the severity of the case where a criterion is not met can be defined. The tripping times report verifies the protection operation times against given criteria. The fault clearing time report also takes into account breaker operation times, and a default value can be supplied. The reports are now executed. From the reports, it is possible to look at the details of any failure or warning. For example, here. The reports can also be exported in HTML or XLS format. Quasi-dynamic simulation is the optimal tool for executing medium to long-term simulations of large power systems. The load flow calculation and quasi-dynamic simulation algorithms have been enhanced by the introduction of user-definable QDSL models. These QDSL models allow the implementation of any customized logic for load flow and quasi-dynamic simulation, such that the users have the flexibility they require when analysing complex power systems with non-standard power flow controllers. Furthermore, the QDSL models allow the representation of time-dependent state variables by simply providing their governing differential equations. It is now possible, for example, to represent the charging and discharging of battery systems, or the behaviour of very slow-acting controllers, or power equipment which require multiple simulation time steps to settle, and many other analyses where time dependency of models is critical. QDSL models employ standard DPL coding syntax, where multiple scripts are used for representing either the load flow equations or the quasi-dynamic controllers. A large number of standard DPL functions can be used within the scripts, whilst a limited set of QDSL dedicated functions are also available. Simulation events can now be applied in the quasi-dynamic simulation. These events can be either predefined by the user before running the simulation, or they can be triggered by the QDSL models, depending on their control objectives. In this example, a very simple setup is built, including a PV system, an AC load and a battery. The PV system automatically calculates the momentary power output depending on the GPS coordinates of the terminal and the actual time of calculation. The load includes a time characteristic that represents a historical estimation of the consumption. The battery is modelled in detail by including a QDSL model. This is the QDSL model controlling the battery power output. Its controller is defined by the model definition object located in the project library. In the basic data page, the model parameters and state variables can be defined. For example, the state variable SOC corresponding to the state of charge of the battery. In results page, all results variables are mentioned, for example, the charging and discharging operation modes of the battery, charge P and charge E. In the initialization script, the initial operating point of the battery is programmed. For example, the initial state of charge of the battery. As you can see, standard DPL syntax is used in the script. Two scripts are available for programming the load flow behaviour of the model, one for the inner loop and one for the outer loop. For quasi-dynamic simulation, the user can input the model behaviour, including the time differential equations, by programming the two available scripts within this page. Going to the quasi-dynamic simulation toolbar and running a simulation for a full day will generate the results shown in these plots. You can see that during the period of high solar insolation, when there is more PV generation than there is load, the battery charges. That is, the state of charge increases. During the evening hours, the battery discharges, such that the load is being supplied. In response to user requests for more flexible calculation options, PowerFactory 2017 offers a new concept of add-on modules. Add-on modules enable users to implement their own functions, which are then integrated into PowerFactory as if they were built-in modules. More precisely, an add-on module command consists of a calculation script in DPL or Python, together with a set of user-definable results variables. These user-defined variables can be used when configuring results boxes, flexible data pages, or colouring modes. Add-on modules open up new options in terms of carrying out calculations and collating and presenting results. I will demonstrate one possible use of an add-on module. In this project, an add-on command has already been set up in the study case. It has been designed to allow the user to run both a short circuit calculation and a load flow calculation and see the results together. The add-on command consists of a DPL or Python script and one or more variable definition objects. The user-defined variables can contain anything from calculation results to element parameters or text strings. The script uses a new create module command to create the add-on module. It may use a range of calculation commands, such as load flow and short circuit. It transfers results variables or other information to the user-defined variables, then uses another new command, finalize module, to complete the add-on module and make the results in the user-defined variables available to the user. Editing the add-on command module, the add-on command, we can see that it has a module name here, which is the name given to the module itself. And when the command is executed, the module is created and this name will appear, for example, when the user selects variables to display on a flexible data page. It also has a module key, which is used internally by PowerFactory. It is used as a reference so that the appropriate flexible data, graphic colouring and results boxes are used when the command is executed. It is possible, if appropriate, for several add-on commands to use the same module key. The command can be executed directly here, or from the Additional Tools toolbar using this icon. Now we can see that the user-defined variables from the load flow and the short circuit calculation are available together. Looking at lines, for example, we can also see that the user-defined variables can be added to the flexible data page. Add-on commands can be made available in the configuration area and linked to the additional tools toolbar. So when the add-on command is executed, the add-on module that is created can be regarded as a bespoke PowerFactory function, handled in the same way as other functions, such as a load flow or RMS simulation, but offering great flexibility for the user. That concludes the PowerFactory demonstrations. I will now talk about some of the other new features in version 2017. There are a number of new and enhanced network models. It is now possible to model a full winding transformer with 1 HV and 3 LV connections as shown here, with a range of configuration options. All calculations are supported, including RMS and EMT simulation, and 2 different data input options are provided. Another enhancement for transformers is the introduction of a current compounding compensation method designed to control transformer voltages within acceptable limits by increasing the voltage set point as the load current increases. For transformers operating with automatic tap changing set to control voltage at the local set point, the existing compensation option has been extended to include the new current compounding capability, where voltage is controlled according to a user-defined voltage control curve. The new harmonic filter element improves modelling capability for filters from the existing shunt filter option. The new elements are used to model single and double tuned and high-pass filters, and again a range of configurations is possible. A new step voltage regulator element has been made available to provide automatic tap control with line drop compensation. Type A and Type B step voltage regulators, i.e. with the tap on the load side and source side respectively, are available. The technology is supported for load flow and RMS EMT simulations. You will have already seen the new output window format. Messages in the output window can be filtered according to message type. There is also an option to filter using a text string. There are other enhancements to the graphical presentation of networks in addition to those demonstrated earlier. As well as allowing the use of pre-configured built-in map services such as Google or OpenStreetMap, PowerFactory 2017 supports the use of user-configured map services based on the standard WMS/WMTS protocol as background maps of the geographic diagram. The available services are defined by the administrator in the configuration folder as shown here, and can be selected by configuring the background layer using the layers command. The geographic diagrams themselves now support the visualization of all elements, including those of negligible physical extent, such as loads and transformers. Moving on to analysis functions, there are several enhancements to the load flow calculations. Convergence is improved by better handling of cases where controllers are initially a long way from their optimum position. There are also several new options to give greater flexibility to the user. For example, as illustrated here, the ability to be selective in terms of element classes when deciding whether active and reactive limits should be observed. The load flow dialog has also been reorganized to make it more intuitive. Looking at short circuit calculations, there are performance enhancements in the complete method which lead to noticeable improvements in runtime, particularly with unbalanced calculations. In addition, there is an option to omit the calculation of transient calculations if these results are not required. If this option is selected, the execution times for unbalanced calculations can be further improved, resulting overall in execution times of about half those in version 2016. There are also significant performance improvements for balanced calculations. In version 2016, a network reduction process based on the REI methodology was introduced. This has now been enhanced to provide short-circuit equivalents both for balanced and unbalanced cases. Two new features in simulations are worth highlighting. The first is an option to reuse existing load flow results when executing calculation of initial conditions. This is particularly useful if multiple simulations are being executed from the same starting point. The second is a new simulation scan module for fault ride-through. This makes it possible to model a fault ride-through characteristic in the simulation. For example, the voltage can be monitored for a set of terminals with the option to display a message or stop the simulation if the voltage is outside limits for more than the specified period. Another new feature is the capability to directly interface external models compliant with IEC 61400-27-1 specifications. The models can be used for both RMS and EMT type simulations, provided they are appropriately designed and intended for RMS or EMT. Although DSL remains the recommended approach for developing models, we recognise that some customers need to develop simulation models of the same equipment in multiple simulation tools. Creating the same model in each simulation tool can be time-consuming and might lead to slightly different results. The generic IEC interface provides an alternative solution by defining a common interface which can be interpreted by any third-party software whilst using the same simulation model core equations. There are also some new DSL functions which will streamline the development of DSL code. For the full list, please see the What's New document. There are several developments in relation to reliability analysis. For PowerFactory 2017, the restoration algorithm is enhanced with an option which allows restoration through a substation. This function is called backward recovery. The algorithm checks for the best feeder to resupply the substation and the interrupted feeders. This can significantly improve the restoration quality for the loss of a substation. The next point refers to the distribution mode of reliability analysis, which implements the optimal power restoration strategies. Previously, this mode was only suitable for radial networks, but in version 2017, it is also possible to use this mode with weakly meshed distribution networks, with a restoration that considers thermal as well as voltage limits. This option is available for configurations where the network is meshed within the feeder, as well as the case where two feeders are defined from one supply point. In PowerFactory 2017, 2 new failure modes for reliability analysis have been added: spurious protection operation and backup protection maloperation. Spurious protection operation models protection maloperation which results in the opening of vent of a breaker without any preceding short circuit. And backup protection maloperation is the incorrect operation of backup protection whilst the fault is being cleared via the primary protection, for a range of reasons such as poor protection adjustment or measurement errors. For both these types of failure, probabilities are provided by the user via the switch object. There are 2 developments in the calculation methods used in the tie open point optimization and phase balance optimization calculations provided under distribution network tools. These types of problems are difficult to solve using classical methods, and these 2 meta-heuristic algorithms are better suited. The genetic algorithm method is newly introduced, and the simulated annealing algorithm, which was introduced in PowerFactory 2016 for phase balance optimization, has now been included as an optimization method for tie open point optimization. Finally, it is hoped that many users will welcome the introduction of a new text editor for DPL, DSL, QDSL and Python. There are many new features which include bracket match checking, a zoom facility and bookmarking. In particular, as illustrated here, there is an auto-completion function which provides the user with possible options and so enables the user to select from a list of functions or methods appropriate to the context. So that completes the presentation, and for further information please look at the What's New document, and more details also can be found in the updated user manual, the updated and new technical reference documents and the release notes. Thank you. I will hand you back to Adrian.
All right, thank you, Deborah. Very informative presentation. We do have a couple of questions coming from the audience. Some of them are relatively specific. For example, there is one: does the snapshot export keep the full project library, or does it export only the library objects that are used? So the answer here would be, with the snapshot export, it will PowerFactory will make sure that only the minimum set of data will be exported, that being only the library objects which are calculation relevant will get into the DZS file. There is another question. If in order to generate the feeder diagram, is it necessary, using the diagram layout tool, is it necessary that the feeders are already defined? And the answer is sure, yes. You would need to manually define them and make sure that they are having the right direction and enclosing the right components. I can see a lot of users have been asking this question. So is it possible to record a webinar, or is it possible to share the recording of the webinar? And shortly the answer would be yes, but we are still not decided on how we will be sharing this information, but we will keep you notified on soon enough. All right, I think There is a question, does the new user-defined modules, can they be used for LVRT scenarios to simulate the voltage of an external grid? So I believe by user-defined modules, you are referring to quasi-dynamic simulation uh, quasi-dynamic simulation models. Um, the answer would be no. You would need to go to an RMS or EMT. Well, usually it's going to be an RMS type simulation. User-defined modules for quasi-dynamic simulation should be used for medium to long-term analysis, and definitely LVRT studies are not part of this. All right, so I think the other questions are a bit more specific, and we will take care of them later on. I do want to thank everybody, Deborah as well for sharing the knowledge with us, and also the audience for the patience of watching the presentation. So thank you. Have a great evening or morning, however the time zone is matching for you.